Good morning students. So this is class 12th physics and today we'll be starting the new chapter number 9, that is ray optics and optical instruments. Okay, so this is the lecture number 1. In this chapter we will be studying about various types of mirrors, rays, how to form ray diagrams using the mirrors, and we'll be studying some optical instruments, for example microscope, telescope, etc. Okay, so let us begin with the reflection of light first. Okay, so all of you know this, that the phenomena of change in path of light without any change in its medium is called reflection of light. That is, whenever reflection takes place, there is a change in path of light, but there is no change in medium. And here, what do we mean by medium? For example, if you have air in one space and if you have water in one space, so therefore we can say there are two mediums. So air and water are considered to be medium here. Okay, so air is medium 1 and water is medium 2. Okay, so now look here, suppose this is a plane mirror. Now how can you define a mirror? Basically a well polished surface on which the light gets reflect on falling on it is called mirror. Okay, so this is the mirror, light is falling on it, so this light will reflect when it will fall on this mirror. Okay, so now this is your incident light and this is your this will be the direction of arrow, because see, this is the incident light, it is coming in this direction, and then this is the reflected light. Now we will be studying about some laws of reflection. Okay, so this is called a normal line on the mirror. Always remember, we always draw a normal line by dotted lines, because normal is a imaginary ray, or you can say imaginary line, it is not real. Okay, so that's why it is denoted with a dotted line. Okay, so now we have two angles, angles of incidence and angle of reflection. So first of all, the angle between incident ray and the normal is called incident angle, and the angle between reflected ray and the normal to the mirror is called reflected angle. Okay, so all of you are familiar with laws of reflection. Let me give you a brief review about them. So the first law of reflection is that angle of incidence is equals to angle of reflection, that is angle I is equals to angle R. Second is incident ray, reflected ray and the normal to the mirror all lie on the same plane. Okay, so that is incident ray, reflected ray and the normal all lie in the same plane. Okay, so if I ask you what is normal incidence, so most of you will say normal incidence means 90-degree angle, but that is wrong. Normal incidence means that the incident ray is falling normally on the mirror. So that means this is your incident ray. If it is falling normally on the mirror, that means this will be your incident ray, this. So now if I ask you what is the angle of incidence for normal incidence? So if the normal ray and the incident ray are coinciding with each other, that means angle of incidence will become 0. And from first law of reflection, that is angle of incidence is equal to angle of reflection, angle R will also become 0. So therefore we can say for normal incidence, that is when light falls normally on a plane, angle of incidence as well as angle of reflection are 0 degrees. Okay, so now because angle of reflection is also 0, therefore the incident ray will retrace its path when it will fall normally on the mirror. Now let us talk about some important terms related to the mirrors and the images formed. Okay, so we have two type of images, real image and virtual image. So real image is that which can be obtained on screen or in which the reflected rays actually intersect. Okay, so if an image can obtain on screen or the reflected rays are actually intersecting, then at that point real image will be formed. Just opposite to that is virtual image, that is virtual image cannot be obtained on screen and reflected rays just appears to intersect but they are not actually intersecting, then at that point your virtual image will be formed. Next is laterally inverted image. By laterally inverted we mean left side becomes right side and right side becomes left side, as in the case of plane mirror. Okay, for example, at your home we have mirrors those those mirrors are plane mirrors. So when you see your image in those mirrors, your left hand appears to be right and right appears to be left. That means that is a laterally inverted image. Okay. Next is inverted image. So by inverted image, we means that the top becomes bottom and the bottom becomes top. That is, top and bottoms get exchanged in an inverted image. And in an erect image, the same image is formed. That is, top remains top and bottom remains bottom. So this is your object, this is your image. Okay, so it will remain same. Now let us talk about the properties of the images which is formed by a plane mirror which we have at our home. So these are the properties. First property is that the image is virtual and erect. Second is that it is laterally inverted. Third is that it is of same size as that of object. Now see, all these three things you see in real life as well whenever you stand in front of your mirror. Okay. Fourth and important property is that the image is formed at the same distance behind the mirror as the object is in front of it. That is, if suppose this is the mirror and if you are standing here at a distance x from the mirror, then your image will be formed at the same distance behind the mirror. That is, this will be the image and it will be formed at the same distance behind the mirror. So we can say the distance between us and our image is nothing but 2x. Okay. So these are the properties of the images formed by a plane mirror. Okay, now let us see how many number of images can be formed by two mirrors, plane mirrors. Okay, so let us suppose there are two plane mirrors which are kept at an angle theta, and now it is asked what can be the number of images formed if a object is placed between them. So here small n is denoting the number of images. So that number of images is equals to 360 upon theta minus 1 or 360 upon theta. Okay, so now see, if 360 upon theta is an odd number, then suppose if 360 upon theta is coming to be 5 is an odd number, therefore 5 images would be formed. If suppose 360 upon theta is coming to be 4 is an odd number, therefore you have to subtract 4 is an even number, therefore you have to subtract 1 from it. That is, 4 minus 1 is 3. So 3 images will be formed. So the formula is 360 upon theta number of images if 360 upon theta is odd, and the formula is 360 upon theta minus 1 if 360 upon theta is coming to be even. Okay. Now that means in both the cases odd number of images is formed by a plane mirror, and the question is why? Because see, odd number is a number of symmetry. For example, see here I have drawn 5 dots. Now if you see, this point is a symmetrical point because 2 points are on the right side of it, 2 are on the left side of it. But now if I draw even number of dots, that is I have drawn 6. Can you find any symmetric point? No. Therefore a odd number is a symmetry number and nature always follows symmetry. Therefore we always have odd number of images formed by these formulas. Okay. Now why many images are formed? That is because of multiple reflection between the mirrors. Okay. So due to multiple reflections, more than one image is formed when two mirrors are kept at any angle. Okay. So now let us start with spherical mirrors. So a part of hollow sphere whose one side is reflecting and other side is opaque is called a spherical mirror. That is, a hollow sphere whose one side is reflecting and another side is opaque, that is called a spherical mirror. Okay. So what we do, we take some part of that hollow sphere and then we call it as a spherical mirror. So I'll show you it how. First of all, let us see about two types of mirror, that is concave mirror and convex mirror. Okay. So all of you are already familiar with it. So the side towards center is reflecting in a concave mirror. That is, see, this is the center. If I complete this would be a hollow sphere. So this is the center of the sphere. Okay. Now suppose I have taken this part of that hollow sphere. Now if its side towards the center is reflecting, that is this side is reflecting and this side is opaque, then this is called a concave mirror. And if the side away from center is reflecting, then that is called a convex mirror. That is, again this is the center, but in this case this side is reflecting, that is outer side, and inner side is opaque. Therefore this one will become now convex mirror. Okay, so now second point is that concave mirror is also called converging mirror and convex mirror is also called diverging mirror. So now what we mean by converging and diverging? So converging mirror means that the light rays falling on the concave mirror, after reflection they will meet at a point or they will go in same direction. Okay, but in a convex mirror, light rays after reflection will go in different direction. Okay, this I will show you in the ray diagrams also. Okay, so for now you can just remember that concave mirror is a converging mirror and convex mirror is a diverging mirror. And as you know, these are the converging rays because all the rays are meeting at a point. So such rays are called converging rays. And if you look at these rays are going in opposite or you can say different directions. So these are called diverging rays. You can remember it like this. See, di means two. So that means there will be two or more directions in diverging rays, and in converging rays there will be only one direction. They will be meeting at a point only. Okay. So this was concave mirror and convex mirror. Now let us talk about various important terms related to the mirrors. For example, your center of curvature, pole, etc. Okay, so the first term is center of curvature and we denote it by capital C. So see, as I told you, the spherical mirror is a part of a hollow sphere. So this is your hollow sphere. This is the part which is taken to be a mirror. Okay. Now this C, that is the center of the sphere of which the mirror is a part of, is called center of curvature. So this hollow sphere has this center. So this center is called center of curvature and is denoted by C. Okay. Okay, so before radius of curvature, let me tell you about vertex or pole. So this is denoted by capital P and the center of spherical mirror is called pole. Okay, so now do not get confused between center of curvature and pole. Center of curvature is the center of this hollow sphere and pole is the center of this spherical mirror. Okay, so this is your center of curvature and this is your pole. And the radius of curvature is the distance between C and P. So this CP is called radius of curvature. Okay, so radius of sphere of which mirror is a part of is called radius of curvature, that is CP. Next is normal to the mirror. Okay, so now see, this is the center of curvature. If you draw any line from C to the mirror, I have drawn two lines, this one and this one. Any line drawn from the center of curvature to the mirror will be perpendicular on it. Similarly, this line will also be perpendicular on it, or you can say normal to it. Okay, so a line drawn from C to the mirror will always be normal to the mirror. Next is principal axis, the straight line joining pole and center of curvature and is extended on both the sides. Okay, so now this line, it is joining center of curvature and pole and it is extended on both the sides. This line is called principal axis. Okay, so next is linear aperture. Diameter A1, A2 of spherical mirror. So now look in the diagram. If I am denoting this point by A1 and this point by A2, then this diameter of the spherical mirror is called linear aperture. And the angle A1CA2, that is this angle, is called angular aperture. Okay, so the next term is focus. Okay, so a point on principal axis at which rays incident on mirror parallel to principal axis passes through or appears to pass through after reflection. That is, if the rays are coming parallel to principal axis, then after reflection they will pass through a point which is present on principal axis and that point is called focus. To understand it, look at this diagram. See, this is your principal axis. As I told you, this is the pole, this is the center of curvature. Now these two are the incident rays and as you can see, these incident rays are parallel to principal axis. Now they will strike the mirror. So now see, a line drawn from the C is perpendicular to the plane of the mirror, or you can say. So as you know, now this angle will be your angle of incidence, that is angle between normal ray and angle between incident ray. And as you know, angle of incidence is equals to angle of reflection. Therefore, this ray will bend like this because this and this angle will be equal. So this is your angle of incidence, this is your angle of reflection. So now this ray came like this, incident ray, it got reflected, and now it will come like this. So this point is called focus. Similarly here, this incident ray is parallel to principal axis. It will also get reflected like this, and it will also pass through a focus. So focus is that point on which the rays incident to principal axis passes through after reflection. Okay. In this also, angle of incidence will be equal to angle of reflection, and similarly if you draw a perpendicular line here to mirror, angle of incidence will come to angle of reflection. Now if we see in case of a convex mirror, again these are the incident rays which are parallel to the principal axis. Now see, because as I already earlier also told you that convex mirror is a diverging mirror, that is after reflection the rays go in different direction. Okay, now again if you draw a perpendicular from C to the mirror, so this dark dotted line is perpendicular to the mirror. This is your angle of incidence. So this is your angle of reflection. So incident ray will go like this. Angle of incidence is equal to angle of reflection. Similarly on this side, this incident ray will go like this. Now as you can see, these are going in different directions. So this is a diverging mirror. Okay. Now see, when you extend these reflected rays, if I extend this ray, it will be get extended like this, and if I extend this ray, it will be get extended like this. So now this point is called focus. And always remember, whenever you extend a line, it will be done by a dotted line because this is your virtual thing. Because see, in real rays are going like this. This is just virtual. So therefore we are extending it like this. So that means here a virtual image will be formed that I'll be telling you in further topics. Okay. So for this ray diagram, just remember these are the virtual lines. Okay. So again in this, the parallel lines, the incident lines which are parallel to the principal axis are passing through a point, or you can say they are appearing to pass through a point on principal axis which is called focus. So I have told you in both the mirrors, that is concave mirror and convex mirror. Okay, so now let me tell you about the sign convention which we will be using to draw ray diagrams. Okay. So first sign convention is that all the distances are measured from the pole of spherical mirror. Okay. So all the distances, that is distance of object, distance of image, all those distances will be measured from the pole of spherical mirror. Second is that distances measured in the direction of incident light are taken as positive and the opposite direction will taken to be negative. For example, look here. This is your concave mirror and this is the direction of incident light. That means the direction from left to right will be taken as positive because the direction of incident light is towards right. So if you are measuring any distance in this direction, this will be positive and this will be negative. Okay. Third is that if by rotating object by 180 degree we get the image, then height of object will be taken as positive and the height of image will be taken as negative. For example, suppose this is your object and this is your image. By rotating this object by 180 degree, we are getting image. That means this height will be taken as positive and this height will be taken as negative. If suppose object was here and image was also here, then will you get image by rotating object by 180 degree if image is like this? Here. No, that means in this case you both will be having same sign. So you can say take both to be positive. Okay. So if you get image by rotating object by 180 degree, then one will be taken as positive, one will be negative, and generally we take object to be positive. Okay. So this is your sign convention. Now Now is some fixed path for some rays. Now let me tell you that, which will help you a lot in drawing ray diagrams, and we'll draw ray diagrams in our next lecture. Okay, so first I have already told you that a line incident on the mirror parallel to principal axis will pass through focus. So this is the one path of ray. Second is that if the incident ray is striking at pole, so see, this is a line which is normal to mirror because it is passing through C. So this is your angle of incidence. So this will be your angle of reflection. So if it is coming like this, it will go like this and make same angle with the principal axis. This is the second path. And third one is very easy. If a ray is incident from the C. Now, as you know, any ray coming from C, that is center of curvature to the mirror, is normal. And as I told you earlier, whenever a ray is incident normally, then it retraces its path. That is, it will retrace its path. So this is angle of incidence and this is angle of reflection only. Okay. So we can use any of these three rays to draw ray diagrams, which we'll be doing in your next lecture. Okay. So go through the lecture because I have discussed all the basic topics in this lecture. From tomorrow, we'll be continuing further. Thank you.